Tuesday. Time to drive back from lunch with Phil. I hear police activity. I see a vehicle driving backwards on the main road on 202. Ah, no, they must be on a trailer. That makes more sense. Where we left off last time, I was talking about the possibility that the universe has a spin. And that is where the chirality of matter and antimatter comes in because of the spin of the universe. And quite coincidentally, I saw a video from Sabina Hofstadter, whom I watch frequently, and she was talking about a recent paper that was published that observed the spin of galaxies had a bias, 70% in one direction, 30% the other, from our frame of reference. And the suggestion for this is expectation would have been 50-50. And to account for this discrepancy, the suggestion was made that the universe has a spin. Of course, they're laying it into the framework of the Big Bang, right? Whereas I don't necessarily need that. I think of it more like the eddy currents, magnetic fields of the planet, the Earth. That motion reinforces structure and structure reinforces motion. So I found that rather, I don't want to say comforting, but confirmation bias, right? It feeds into my confirmation bias. Makes my confirmation bias happy. And the coincidence is interesting too, that the universe, my thoughts were rather spontaneous the other day. And the YouTube video by Sabina was serendipitous and deliberate. Did I tap into what was going to be said, or is it purely coincidence? I know. I tend to read too much into these things. But it's interesting. Now, what I was really going to talk about today, and we'll get into this now, is wave-particle duality. description that a photon, at least action, we tend to think of it in terms of 3-space, 4-space, you want to factor time in. I don't like time. It's sequence, measured sequence on a particle system. That we will see essentially that the photon itself is exploring all paths by going through all parts of the universe on an opportunistic basis through Dodic space. And I tend to think of this in terms analogous to, or a similar mechanism causes the phenomena of lightning and the stepped leader, where the stepped leader is a branching structure of charge channels that are reaching from the cloud to the ground and the ground to the cloud, based upon the buildup of charge difference. Giant capacitor in the air is a giant capacitor until it short circuits via the step leaders. And the step leaders are exploring cubic space, but they use Dodic space, but they're exploring cubic space. Exploring. They're manifesting is probably a better way of saying it. They're manifesting in cubic space. But it is a breadth first search? Depth first search. It's a breadth first search for a pathway to ground or to opposite charge. And when the breadth first search, the comp sci term, depth first search will go immediately to the ground. The breadth first search is just constantly branching and trying. That's a cubic representation. If you're down at the photon level, it's doing the same sort of thing, but it has the palette of its entire field plus Dodic space. Because it's so small, it can traverse Dodic distances. Cubic space is almost incidental to its search, but it's the structure of the particle itself doing a breadth first search, similar to a step leader within cubic space, for the next location that it needs to go. And the fun part about lightning is that once it makes that connection between cloud and ground, that the charge within all of the other branches is dumped back. It goes, and then one hits, this one drains, then this one drains, then this one drains, then this one drains through the same channel, so you get the multiple flashes. You know, lightning only strikes once in a place, but it releases multiple strokes through the branching the term is for it, I've said it 12 times. Step leaders. It says the step leaders dump their strokes of lightning down the connecting path. Well, with a photon, essentially the stroke, if you will, is the photon itself taking the next step in its translational journey through the universe. And as it does the searching, it loses a tiny bit of energy through Dodic space, which is steps in the sequence of its propagation throughout the universe, those low probability events of energy being taken accumulate to a little bit of a red shift, or a lot of a red shift. The further you go, the more chances there are for this to happen. Can we observe how and where these interactions occur? Not really. I mean, we'd have to be at the scale of the Planck length and be able to operate as an intelligence of some sort of probe and be able to recognize that we're in any particular part of the rest of the universe somehow at that scale where locality, the frame of reference is so small that it doesn't matter until an entire particle at most pops through. But we're talking about being in this spaceship the size of a neutrino or smaller, Planck length spaceship. This is fantasy land experiment. So the photon, as it translates through free space, this is where the principle of least action comes from. And the idea, the model that people talk about, that it explores all possible paths. It's not as literal as that. It's more that it is capable, or that it is an emergent quality, no, that it is an functional, operational nature of translation motion, that it interacts with all parts of the universe. And the statistical depends on the folding of Dodic space itself, and how much it's likely to do things that are in cubic space mass, interact with parts of cubic space that are vastly separated, whereas in Dodic space there may be a fold that makes vastly separated parts close. And once the particle, the photon, is captured within the structure of an atom, it now experiences vibrational energy. It's in the world of chemistry right now. And that vibrational energy still operates according to the same principle of least action and interaction with the entirety of the universe, but it is constrained within the confines of the structure of the atom. And as such, it will not tend to redshift. It will have a discrete energy that is preserved because it is protected. So when energy might be stolen by some other part of the universe, it's stolen but given back by the atom itself, and it has an abundance to give because of the strange attractor of the definition of the atom. The strange attractor of the definition of the photon is very bounded, and that's why giving away energy, it can't get it back when it's free. In fact, it doesn't even try. But when it's within the bounded structure of an atom, the strange attractor is so large, it has a slush fund, if you will, such that if the photon, which is captured, loses something, the atom gives it back immediately, or the photon takes it from the atom immediately. The atom never notices because it's used error of structurally and vibrationally stable. So photons get protected within the confines of an atom. Now, that's not to say that you can't re-emit the photon at a different wavelength based upon the entry angles and exit angles into the photon itself. It's an interesting question. Something that very fundamental that I should know the answer to is the absorption spectrum of an atom that's complementary to its emission spectrum on a one-for-one basis, or is there any difference there? I imagine there is a difference. And again, it goes back to that thought of, is it easier for a photon to be captured than emitted? I think it's slightly easier to be captured than emitted. Why? It goes back to the strange attractor of the atom itself, and it's got a essentially variable mass, by which allowing a photon to come in and vary the mass of the overall system with the inclusion of the photon is more easily accommodated. And then the strange attractor, if you accumulate enough photons, you start spinning them out, they're not acceptable. Might be a better way to put it. So yeah, it has to do with the slush fund of the structure of the atom itself. It's more readily able to accept additional mass than it is to give it up. It seems kind of lame argument. I don't know. I haven't thought about that until now, so let's do some experiments. See if we can get some empirical information on that. Probably already exists. Just need to find it. I haven't heard about it. So, okay, wave particle duality. Now, double slit experiment. Since the particle, the wave is a particle, and the particle is a wave, and I'm talking about it being, when the photon's captured within the construct of an atom, it is more like a particle than a wave, but it is still a process, or a sub-process within the strange attractor of the atom itself. But it is not a discrete thing. It is part of the atom. Failed to mention that. Should have mentioned that a little sooner. When a photon enters an atom and gets captured, it is part of the atom. It is not a discrete thing. It may have properties that it contributes to the atom itself, but in and of itself, it's still not discrete. I mean, when we get into quarks and stuff like that, I don't see them as being discrete. I see them as being parts, units of mass, or bundles of mass that contribute to an internal process that, when freed, become pseudoparticles. Particles enter pseudoparticles depending on how stable they are. Virtual pseudoparticles. I gotta go back to that discussion for 2 lectures, 4 lectures ago. Anyway, so photons. So wave particle dualities, this nature of step leader search throughout space, where the least action principle is strongest within local space, cubic and tetric, through the slits, their step leaders physically interact with each other in a way that is mathematically and representationally on the target screen have a nodal wave-like distribution, bands of stronger energy and weaker energy. But when the particles hit the target, the step leader collapses just like a lightning strike. So it is a particle that hits the target, but its distribution is according to the step leader effect within cubic space primarily, but it's an emergent behavior of tetric space. It's tetric space step research, where dodic space has some perturbation on where those individual strikes may occur, becomes the element of the factor, that feeds into the likelihood, the probability, the chance of any particular place on the target being struck. But local space has its influence, cubic space, tetric space, and cubic space both have their own influences too. So least action, searching all paths. So the observation or the projection onto the screen of a pattern, interference pattern, wave-like interference pattern, is almost a mathematical phenomena. It's a physical phenomenon, whereas it's being reported, it's like a printout, if you will, of the behavior of the photons or the electrons. And the curiosity is if a single photon going through the double slit interferes with itself. Well, it can't. It has to resolve somehow. Have an individual basis, it would have a distribution. If you shot them one at a time, a distribution that would look very much like the wavefront because it's interfering with itself. And that's where all that comes from. Anyway, the universe has spin. That's where antimatter comes from, or matter-antimatter. Imbalance comes from. At least I think so. Boomer. Boomer.